Today we're going to begin learning about systems of equations. So we need to start with a definition. A system of equations is going to be, in our case, two equations. So we're going to learn to take two equations and solve what we call a system of equations to get a solution that fits both of those equations. So right here at the beginning it says create your own system of equations. So I'm just going to write two equations. That will be my system of equations. So y equals 3x minus 1. And then for a second one, I'll write y equals 2x plus 3. That's all a system of equation is. Two equations that we can then solve. So in this first example, it's just giving us a point, 2, 5, and it's saying prove that that point is a solution to the system of equations. Well, the only way that that point can be a solution to both is if it makes both of the equations true. So we're going to actually plug in that 2 for x and the 5 for y into each equation and see if it makes them true. So I just went in and I plugged in the 2 for the x and the 5 for the y. I plugged them in using parentheses and I checked, and both of those equations become true. So yes, 2, 5 is the solution for that system of equations. Now number 2 asks, is this point, negative 2, 0, a solution for the following system? Well, the way to find out, again, is to plug it in and see if it makes it true. So in this system, when I plugged in the negative 2 for x and the 0 for y, it made the first equation true. So I thought, great, looks good. But then I plugged it into the second equation. It did not make it true. So no, this is not a solution to that system of equations. Okay, so we can have three different kinds of solutions. We can have our two lines both cross. They'll cross in one spot, and when they cross in that one spot, there's one solution. So 1 point makes that solution true. The second option would be when we have parallel lines. Those parallel lines are never ever going to cross. Therefore, there's not going to be a solution to it. And then the third option could be the lines are the exact same. So the lines actually lay on top of each other. And when we have that, it's called infinite solutions. Every single point is a solution to that system of equations. So every time you're looking at a system of equations, you'll either be looking for where they intersect, which will give you one solution. You will be looking to see if they're parallel lines, so there's no solution, or if it's the exact same line, so it is infinite solutions. All right, so we're going to learn today about how to find our solutions graphing our system of equations. The good news is when we graph it, the calculator can actually give us the point of the solution. So the first thing we have to do is we have to get our two systems into a graph. So when we're looking at these two equations that they've given us, neither one of them are into the y equals format. So the first thing we're going to have to do here is we're going to have to put them both into y equals, which means we're going to have to solve for y. So go ahead and pause your video, solve both of these equations for y equals, and then start the video back up and check your work. Okay, so I solved both of these equations, have them both in to my y equals key. And then I've just put them onto the graph. So my first equation here at the bottom, y equals negative 5 halves plus 1/2 x. So I have to go to the negative 2.5, and that's where I'm going to start my line. So negative 2.5, and then my rise over run is going to be up 1 over 2. So up 1 over 2, and that gives me a dot, and that's how this line was formed. Now my second one, y equals negative 5 minus 2x. So my -5 is my y-intercept. So we're going to put that right there. And then on this one, it's going down 2 over 1, or up 2 backwards 1. So that's how I got my second line. When I draw these two lines, I have a spot right here that both of the lines connect. That is my solution to this graph. So if I look, that's -1 and -1, 2, 3. So my solution is -1, comma, -3. Now, the way that I would check the solution is I would plug them both back in and verify that both of them make the equations true. But I would plug them back into my original two equations. That way, if I've made any errors in my solving, I will know that I've gotten it wrong because I'm using the originally given equations. So I just plugged in my solution, -1, -3, into my original equations, and both of them came out true. Now I want to show you how to use the calculator in order to solve systems of equations. So if you'll notice, we've actually written the calculator steps out here for you. So you might want to make a big old star or an exclamation point or smiley face or something so that you'll know this is where you need to come back to get the steps of the calculator. You'll notice today's work, I've already got them all solved into y equals. But when we start the work on the next couple of classes, you're going to be required to solve them into y equals. But today I really want to get you good at putting it in the calculator. So you're going to go to your y equals button, and you're going to put in the first equation as y1 and the second equation as y2. And once I put those in the calculator, I'm just going to press graph to make sure I have intersecting lines, nothing parallel and not the exact same line. And then I'm going to press second, calculate the number 5, and press enter 3 times. And when I do that, it gives me my intersection of -1, 4. Okay. I want you to go ahead and do number 5, 6, and 7 using the calculator, putting them in the y equals, pressing second calculate, going down to number 5, which is the intersection, and pushing enter 3 times. That'll give you practice, and then start the video back up and make sure that your answers are the same as mine. Okay, so when you did number 5, you were able to get a solution, but notice when you did number 6, it was the exact same line. I mean, you can look at the equations and see they're the exact same lines. It's infinite solutions. And then on number 7, what made number 7 no solution? Well, if you look at the slope, they were the exact same. We had parallel lines, and that made it no solution. Okay, so here's 2 more. Go ahead and put them in your calculator, get the solution, turn the video back on, and check. So again, check your solutions. Notice on line B, they made parallel lines, so there was no solution. Okay, so on this third page, we're actually going to put it into a full problem. So we first have to look at the problem and write our equations. So what we have is y equals, and we're talking about Coach Smith, runs 2 feet per second. So he's going to be our 2x. And then for Mr. Ashcraft, we have him at 1 foot per second, plus, since he's old, he got a 10-foot head start. So those are my 2 equations. So I'm going to go ahead and put those into the calculator, and I'm going to look for my solution, because my solution is going to be when Mr. Ashcraft catches up with Coach Smith. When their 2 lines connect, or when their 2 lines intersect, that's going to be the solution. So when I look at my solution is actually 10, 20. So my 10, 20, 10, my x value is talking about the time, the seconds, and 20 is my y value, talking about the feet, how far we went. Okay, so now let's look at number 9. I want you to think about which of these systems will be more difficult to solve and why? So I'll give you a minute to look at it. If you notice, neither one of them are already in the y equals format. If you have one of them in y equals, that would definitely be the easiest. But when I look at these, this first system, one of the equations is in y equal, and the other equation, it's going to be very simple to put into y equals. So if I had to choose which systems I was going to solve, I would definitely pick this first one. It's going to be easier to put in the calculator. All right, so let's look down here. Oh, no, we're not going to do the exit ticket. So that's the end of the video. Come into tutoring if you need more help, or if you need to check out a calculator, stop by and let me know, and I will get one checked out for you.